Observing and predicting constant velocity motion. Our objective for this experiment is to collect position data for a moving object, which is the horse on the treadmill coming up. We will then use this data to form a predictive model, which we will then compare to our tracked data. Tracker allows us to plot the position of the horse on the treadmill at different time intervals so that we can take data points to then graph. We will use our data extracted from Tracker to develop a predictive model. We will do this using a derived version of Newton's second law that lets us find the final velocity. We take our initial velocity and our initial position of the horse that we tracked in Tracker, and we plug it into our velocity formula to find the next position of the horse at our next increment in time. We then take our initial velocity point and plug it back into Newton's formula to find our next velocity point. We would have to repeat this process many times to gather enough data points to build our predictive model. This computer program essentially does this for us just many times so it wouldn't take so long to do it by hand. Our next step is to graph our model position data versus our tracked position data. As you can see, the model position data is a perfect line, and that is because it is assuming the ball is moving at exactly negative 2.6 meters per second in the x-axis. The reason our tracked graphed position data is not perfectly aligned is because we could have had some random error when clicking on the horse in Tracker, or the horse's constant velocity could have been different than 2.6 meters per second the entire time. As you can see, in the beginning the two lines appear to be the same, but because they are divergent, they will be significantly different in the future. As you can see here, the top graph is reflective of what our graph in Tracker reflects. On the x-axis to the left is negative, like our horse, our object, is moving to the left, so our data points for position are negative. If we would have flipped it, all that would mean is that to the right would be negative and to the left would be positive, so all of our data points that read negative would read positive and vice versa. We know there is a force acting on the horse because the motor of the treadmill is pushing the horse, but we can assume that the net force is zero because it has a constant velocity.
If you